Let us start with the first simple heterocyclic compound, pyrrole. Okay, this is the structure of pyrrole. It is five-membered nitrogen-containing heterocycle. Pyrrole is example of five-membered nitrogen-containing heterocycle. Okay, this is the structure of pyrrole. किंवा आपण याही पद्धतीने दाखवू शकतो. Here, actually, this is the geometrical figure. Here, this corner means CH, carbon आहे तिथं, having one hydrogen. Here also carbon having one hydrogen, CH, then NH, and it having two double bond. This is conjugated diene. त्याला आपण two double bonds असं म्हणूया in conjugation. Okay, this is the pyrrole structure of pyrrole. Now let us see some introduction. Yes, it is five-membered heterocycle. Then it occurs in coal tar and bone oil. It is also found in hemoglobin, chlorophyll. It is also present in some alkaloids, vitamin B12, etc. Okay, then it is also known as azole. That compound is also called azole, and this is the IUPAC name of pyrrole. 1-aza cyclopentadiene. Actually, it is example of cyclopentadiene. यामध्ये आपण या पायरॉलचं डिटेल डिस्कशन करणार आहोत. मग यामध्ये पायरॉलचं सिंथेसिस असेल किंवा त्याच्या काही प्रॉपर्टीज आहेत, केमिकल रिॲक्शन्स आहेत, त्यामध्ये इलेक्ट्रोफिलिक सबस्टिट्यूशनचं मेकॅनिझम असेल, तर याचं थोडंसं डिटेल डिस्कशन आपल्याला करायचं आहे या टॉपिक मध्ये. नाउ लेट अस सी सिंथेसिस ऑफ पायरॉल, how that heterocyclic compound is prepared in laboratory. तो लॅबोरेटरी मध्ये कसा सिंथेसाइज करायचा हे थोडंसं बघणार आहोत by using simple method. And first method is by using acetylene and ammonia. Okay, acetylene, you know that acetylene is very simple compound, CH triple bond CH. Okay, now let us see, this is CH triple bond CH, acetylene molecule. Okay, when that acetylene molecule is treated with the ammonia, NH3 ammonia. Now in this reaction, two molecules of acetylene participate. This is the second molecule of acetylene. Now that mixture of acetylene and ammonia, it is passed through red hot tube. Now what happens here, that two molecules of acetylene and ammonia, it undergo condensation. That's a condensation होतं, and we get the cyclic compound having two double bond, one nitrogen atom, and this is nothing but the pyrrole. याला आपण pyrrole असं म्हणतो. Means that two molecule and one ammonia molecule, it undergo condensation. इथून एक हायड्रोजनचा एक H2 molecule फक्त बाहेर पडतो, and there is a formation of pyrrole. आणि या ठिकाणी five-membered cyclic compound तयार होतो, which having nitrogen atom, and this is nothing but the pyrrole. याला आपण pyrrole असं म्हणतोय. Okay, this is just first method. पहिली मेथड आपण बघतोय सिंथेसिस ऑफ pyrrole मध्ये by using acetylene and ammonia, who the pyrrole is prepared. Okay, now let us see second method from furan and ammonia. Actually, furan is example of heterocyclic compound. It is oxygen heterocycle having oxygen atom. Okay, now when that furan is treated with ammonia, it is treated with the ammonia, and that reaction is carried out in the presence of alumina, Al2O3, and steam at high temperature. That reaction is carried out at high temperature in presence of alumina. Now what happens here, that oxygen atom from the furan is replaced by NH group. यामध्ये NH group ने replace होतो, means oxygen is replaced by nitrogen, and we get the corresponding heterocycle. This is nothing but the pyrrole. Okay, now that oxygen atom and remaining two hydrogen atom, we can say simply formation of water molecule, H2 molecule, and thus replacement of oxygen atom takes place by NH group, and we get the corresponding pyrrole. This is the second method, and in this method we can prepare pyrrole on large scale. This is the manufacturing process method for the preparation of pyrrole by using furan. Okay, now let us see third one. And in the third method, pyrrole is prepared by using succinamide. Now what is the succinamide? Okay, this is the structure of succinamide. Actually, this is the amide of succinic acid, hence called succinamide. CH2, CH2, C double bond O, again C double bond O, here NH. This is the succinamide. Okay, but this is the keto form of succinamide. थोडंसं रिएक्शन तुमच्या लक्षात यावी म्हणून मी याचा इनॉल फॉर्म दाखवतो. इट अंडरगो टाटोमेरिझम, अँड दिस वन इज द इनॉल फॉर्म. इनॉल फॉर्म मध्ये सिंपली आपण काय म्हणूया, इथलं वन हायड्रोजन ॲटम गोज ऑन द ऑक्सिजन, and this double bond goes in between that two carbon. तुमच्या अंडरस्टँडिंग साठी हे लक्षात ठेवा. and we get the enol form. Here also इथला डबल बॉन्ड इथं जाईल आणि इथला हायड्रोजन इथं येतोय. We get the enol form. Okay, this is the enol keto form and this one is the enol form of the succinamide. Okay, now this enol form of the succinamide participate in the reaction, and when that succinamide is treated with the zinc metal in presence of acetic acid, now how the reaction occurs? That succinamide loses one oxygen atom. There is a loss of that oxygen atom, and here that hydrogen atom directly attached to carbon. Now this oxygen and this zinc form ZNO as a byproduct. Similarly, that oxygen atom and another zinc atom form one more molecule of ZNO. That hydrogen is directly attached to carbon, and now there is a formation of such compound, 5-membered, nitrogen having heterocycle, and this is nothing but the pyrrole. Okay, plus there are 2 molecules of ZNO, and this is just the pyrrole, our expected heterocyclic compound, and this is the third method used for the synthesis of pyrrole. आपण या टॉपिक मध्ये आतापर्यंत काय बघितलं होतं? हाऊ द पायरॉल इज सिंथेसाइज्ड. मग यामध्ये 3 आपण वेगवेगळ्या मेथड स्टडी केला सिंथेसिस ऑफ पायरॉल मध्ये. फर्स्ट बाय युजिंग ऍसिटिलीन अँड अमोनिया, त्यानंतर सेकंड मेथड आपण बघितलं फ्युरॅन अँड अमोनिया, आणि थर्ड मेथड आहे त्याचं बाय युजिंग सक्सिनामाइड. वी हॅव स्टडीड सम सिंथेटिक मेथड्स, some synthetic preparation methods by the pyrrole, how that compound is prepared in laboratory. Now let us see next point, some physical properties of pyrrole. In short, आपण या कंपाऊंडच्या काही फिजिकल प्रॉपर्टी आपण बघणार आहोत, and then we will go towards next point. First one is pyrrole is a colorless liquid. Actually this is a colorless liquid compound, but when it is exposed to the air, it converts or it darkens and finally form a resinous mass. Its boiling point is 131 degree Celsius. त्याचा boiling point 131 degree Celsius एवढा आहे, and it is sparingly soluble in water. Sparingly means very very less soluble in water. कमी प्रमाणात तो पाण्यामध्ये soluble आहे, and it is easily soluble in organic solvent like alcohol and ether. Organic solvent मध्ये मात्र तो easily soluble आहे. फॉर एक्झाम्पल अल्कोहोल, इथिल अल्कोहोल असेल किंवा इथर असेल, यामध्ये त्याची सोल्युबिलिटी चांगली आहे किंवा तो इझिली सोल्युबल आहे. ओके, दिस इज जस्ट अबाउट द फिजिकल प्रॉपर्टीज ऑफ पायरॉल. नाउ लेट अस सी aromaticity and resonance effect observed in pyrrole. Means how it shows the resonance effect, how it is aromatic compound, हे यामध्ये आपल्याला स्टडी करायचं आहे. दिस इज अ स्ट्रक्चर ऑफ पायरॉल. ओके, नाउ दिस पायरॉल having, actually this is 5-membered compound having 2 pi bonds, right, and there is 1 electron pair. Now what is meant by aromatic compound? First tell me what is aromatic compound. According to the Huckel's theory, compound should be cyclic, planar, fully conjugated, and it should be contain 4n plus 2 pi electron. Then it is called aromatic. That compound should be cyclic. तो cyclic असावा. It should be planar, means all the atoms of cycle should be lies in a single plane. Then it should be full conjugation. There should be alternate and single double bond, means there should be full delocalization of electron on the cycle, and it should contain 4n plus 2 pi electron. 4n plus 2 pi electron means it should have 6, 10, 14, etc. pi electron. Then it is aromatic compound. Now what's about the pyrrole? Actually it having only 2 pi bond. There are only 2 pi bond. Each bond contribute 2 electron, means there are only 4 pi electron. Okay, what we are looking, that pyrrole having only 4 pi electron, means it do not having 4n plus 2 pi electron. Therefore what is our observation? Our first observation is that pyrrole is not aromatic compound. Yes, it is cyclic, it is planar, okay, but it having only 4 pi electron, and therefore it is not aromatic. This is our first observation. But in actual condition, pyrrole is example of aromatic compound. Pyrrole shows aromaticity. Now question arises, how the pyrrole shows aromatic nature? Why it is aromatic compound? हे आपण स्टडी करणार आहोत with the help of resonance effect in the pyrrole. म्हणजे आपण दोन्ही गोष्टी कोइन्सिडेंटली स्टडी करतोय. हाऊ द पायरॉल शोज रेझोनन्स इफेक्ट and how it shows aromatic nature. Okay, we know that in pyrrole there is one nitrogen atom. Okay, there is one nitrogen atom and it having lone pair of electron. I have shown that lone pair of electron on the nitrogen. Okay, now this is first observation. Pyrrole contain conjugated diene. This is diene. Diene means there are two double bond in a molecule. This is diene. One double bond, second double bond, therefore diene. And these double bonds are in conjugation. Means there is alternate single and double bond. म्हणजे double bond, single bond, double bond. This is called conjugation. And this pyrrole is a conjugated diene. Okay, hence what we are expecting, yes, it should be undergo addition reaction. Pyrrole contains two double bond. This is conjugated diene. Therefore, what is our expectation? Yes, it should be undergo addition reaction. Let us see example. This is simple 1,3-butadiene. This is simple 1,3-butadiene. Example of again conjugated diene. Okay. Now, when that diene is treated with the chlorine, it undergo addition reaction, and we get 1,4,2 butene, and this is just example of addition reaction. Now similar to that 1,4-butadiene, all the dienes, all the alkenes, all the unsaturated compound, they undergo addition reaction. This is the characteristic property of unsaturated molecule. This is the characteristic of aliphatic unsaturated molecule, that they should be undergo addition reaction. They contain pi bond, they contain a two double bond. Therefore, our expectation is that that compound should be undergo addition reaction. Okay, but however, pyrrole undergo electrophilic substitution reaction instead of addition reaction. Okay, our expectation is that pyrrole should be undergo addition reaction, but in actual condition what happens? Pyrrole do not undergo addition reaction and it undergo electrophilic substitution reaction. Actually, electrophilic substitution reaction is a characteristic property of aromatic compound. It is characteristic property of aromatic compound, and here that pyrrole undergo electrophilic substitution, it do not undergo addition reaction. Actually, pyrrole contains NH group. This is NH group, and NH group is the secondary amine. Means pyrrole contain secondary amino group, but it is not. What is our expectation? Yes, it should be shows properties like secondary amine, but that pyrrole do not possess properties of secondary amine also. Means these are the two main observation. पहिलं observation कोणता? Pyrrole undergoes electrophilic substitution reaction instead of addition. It do not shows addition reaction, but it shows electrophilic substitution reaction like aromatic compound. Then second, it do not possess properties of secondary amine. Secondary amine properties सुद्धा तो दाखवत नाही. Now what should be the conclusion from that? Yes, this indicates that pyrrole is a aromatic in nature. याच्यावरून काय ऑब्झर्व होतं? Yes, it should be aromatic in nature, and lone pair of electron which is present on the nitrogen. Okay, this is the lone pair of electron which is present on the nitrogen, and that lone pair of electron, it should be involved in the delocalization. ही electron pair delocalization मध्ये involved होते, and there is aromatic sextate. There is aromatic sextate. Okay, now let us see how that pyrrole undergo delocalization, how the electron pair on the nitrogen involved in the delocalization means how the pyrrole shows resonance effect. How the pyrrole shows resonance effect. Now let us see how the pyrrole shows resonance effect, how that electron pair is delocalized. Now what happens in the first step? Yes, this electron pair form a pi bond between these two atoms. This electron pair form a pi bond between two atoms. Therefore, the next pi bond, this pi bond undergo breaking, and that electron pair goes on the next atom. Okay, and we get the first resonating structure. आपल्याला पहिलं resonating structure मिळेल. Now here there is a pi bond. Here there is a pi bond. Okay, now here pi bond occurs, therefore nitrogen acquires positive charge. While this pi bond undergo breaking, electron pair goes on the next atom and next atom acquire negative charge. Here there is a negative charge and we are having first resonating structure for the pyrrole. Okay, and thus this is the resonating structure for the pyrrole. Again, carbon having negative charge means there is an electron pair. There is an electron pair. Now this electron pair again undergo delocalization. Again undergo delocalization. This electron pair now form a pi bond between these two atoms. Okay, now therefore to maintain the valency of next atom, what happens? This pi bond now undergo breaking. या पुढच्या pi bondचं breaking होतं and this electron pair goes on the next atom. तो पुढच्या या ठिकाणी कार्बन वरती जातो. Thus new pi bond is here and now this carbon acquires negative charge. पुढच्या कार्बन वरती negative. Here this is new pi bond while that carbon now acquires negative charge. Okay, this is next resonating structure for the pyrrole. Now what should be the next step? पुढची स्टेप काय असेल? Again this negative charge means electron pair form a pi bond between these two atoms. या दोन्हीच्या मध्ये pi bond तयार करेल like that. Okay, therefore this pi bond पुढचा हा pi bond break होतो and this electron pair goes on the next atom. पुढच्या atom कडे ही electron pair जाते. We get the another resonating structure. Okay, here this is new pi bond. इथं नवीन pi bond असेल आणि इथला pi bond break होतोय and electron pair goes on the next atom. Therefore this carbon acquires negative charge. Now this carbon acquires negative charge. We get the another resonating structure for the pyrrole. Okay, this is the another resonating structure for the pyrrole. Again there is a negative charge means electron pair. Again this electron pair undergo delocalization. This electron pair form a pi bond between these two atoms. Therefore next pi bond undergo breaking. This electron pair goes on the next carbon atom and it acquires negative charge. Now there is a new pi bond here and here there is a negative charge on the carbon and thus that electron pair from the nitrogen, it delocalizes in the pyrrole, it delocalizes in the ring and we get a number of canonical structure. This is called resonance effect. This is called resonance effect. We have studied how the electron pair from the nitrogen is delocalized in the ring, how the pyrrole undergo delocalization and how it shows the resonance effect. Now question arises, what should be the conclusion from that resonance effect? What should be the conclusion? Yes, how many electrons are delocalized in the pyrrole? How many total electrons are delocalized in the pyrrole? There are two pi bonds, दोन pi bonds आहेत. This pi bond, each bond contributes 2 electron. म्हणजे याचे 2 electron, this 2 electron. Then again second pi bond 2 electron, while 2 electron from the nitrogen. This 4 pi electron and 2 electron from the nitrogen. Thus in this case total 6 electrons are delocalized. In the pyrrole total 6 pi electrons are delocalized in the ring, means that pyrrole obeys Huckel's rule. Pyrrole obeys Huckel's rule because it is cyclic compound, it is planar, fully conjugated and having 4n plus 2 pi electron. Why it possesses 4n plus 2 pi electron? Because there are total 6 pi electrons are delocalized over pyrrole ring. 4 electron from the 2 pi bond and 2 electron from the nitrogen. Thus total 6 electrons are delocalized, means there is a 4n plus 2 pi electron. Hence it is aromatic in nature and thus pyrrole is a cyclic, planar, fully conjugated and contains 6 pi electron. That is 4n plus 2 pi electron. Therefore it is aromatic in nature. Thus pyrrole is a resonance hybrid of the different canonical structure and hence it is a stable and aromatic compound. Pyrrole is an aromatic compound, hence it shows electrophilic substitution reaction and it do not undergo addition reaction. पहिले जे ऑब्झर्वेशन आपलं होतं, पहिले जे एक्सपेक्टेशन होतं, yes it having 2 double bond. Therefore what is our first expectation? Yes, it should be undergo addition reaction, but it do not shows addition reaction because it is aromatic compound. That electrons are delocalized and therefore that pi bonds do not undergo addition. Okay, they show इलेक्ट्रोफिलिक सबस्टिट्यूशन रिएक्शन लाईक एरोमॅटिक कंपाऊंड. आणि आपण आता या ठिकाणी प्रूव्ह केलेलं आहे हाऊ द पायरॉल इज एरोमॅटिक कंपाऊंड विथ द हेल्प ऑफ रेझोनन्स इफेक्ट इन द पायरॉल. ओके, दिस इज जस्ट अबाउट द व्हेरी इम्पॉर्टंट कन्सेप्ट हाऊ द पायरॉल इज एरोमॅटिक इन नेचर, हाऊ इट शोज रेझोनन्स इफेक्ट. नाउ लेट अस सी रिएक्टिव्हिटी ऑफ पायरॉल. यामध्ये आपण काही कन्सेप्ट स्टडी करतोय. हाऊ द पायरॉल शोज बेसिक कॅरेक्टर, हाऊ द पायरॉल शोज acidic character, etc. We know that pyrrole having NH group means it is having secondary amine group. We know that secondary amine is example of basic compound. Secondary amine NH compound, they are basic in nature, but what happens here that pyrrole is very weak base than regular secondary amine, and also pyrrole shows somewhat acidic character. It is not strong acid but shows somewhat acidic character. So let us see how the pyrrole is basic in nature, why it is weak base, and how it shows acidic character. Okay, now what is meant by basic nature? Yes, tendency of substance to donate electron pair. Okay, according to the Lewis theory, if compound donate electron pair to another substance, then it is called base. Okay, this is the Lewis theory. Or suppose it accept proton, then it is also called basic. Okay, then tendency of compound to donate electron pair or to accept proton is called basicity. This is called basic nature. This is called basic character. Okay, this is first concept. Now we know that, consider example of primary amine. Here also nitrogen having lone pair of electron, and this compound can donate this electron pair to another substance, or it can be accept proton, and therefore it is basic in nature. Okay, just primary amine, why it is basic? Yes, it having lone pair of electron. Okay, this basic nature of nitrogen compound is due to the lone pair of electron under nitrogen. I have told primary amine, ammonia, secondary amine, tertiary amine, they are basic in nature. Why they are basic? Because they having lone pair of electron under nitrogen. This nitrogen can donate this electron pair to another compound, hence they are basic in nature. This is regarding common nitrogen containing compound. Now let us see example of pyrrole. In pyrrole, what happens? Nitrogen having lone pair of electron, but this lone pair of electron is involved in the delocalization. In pyrrole, we know that this electron pair is involved in the delocalization. आपण मगाशी पाहिलं होतं how this electron pair is involved in the delocalization. It is involved in the resonance effect, and therefore it is not easily available for donation and protonation. This electron pair is not easily available to donate to another compound, and therefore pyrrole is a weak base. Therefore pyrrole is a weak base. Why it is weak base? Because in pyrrole lone pair of electron is involved in a delocalization. ही जी इलेक्ट्रॉन पेअर आहे, ही इलेक्ट्रॉन पेअर डिलोकॅलायझेशन मध्ये इन्व्हॉल्व झालेली असते. त्यामुळं पायरॉल ही इलेक्ट्रॉन पेअर दुसऱ्या कंपाऊंडला इझिली देऊ शकत नाहीये, and hence it is weak base. Okay, now let us see how it shows basicity. तो basicity कसं दाखवतो? weak base असला तरी बेसिक आहे. It dissolve very very slowly in cold and dilute HCl. कोल्ड आणि डायल्यूट HCl मध्ये तो या ठिकाणी स्लोली डिसॉल्व होतो किंवा HCl बरोबर रिॲक्ट होतो. मीन्स इट इज बेसिक इन नेचर असं आपण म्हणू शकतो. ओके, दिस इज अवर रेझोनेटिंग स्ट्रक्चर ऑफ पायरॉल. हे आपलं पायरॉलचं मगाशी दाखवलेलं रेझोनेटिंग स्ट्रक्चर आहे. व्हेन इट कम्स इन कॉन्टॅक्ट विथ HCl, काय होतं HCl बरोबर कॉन्टॅक्ट आल्यानंतर? हिअर दिस इलेक्ट्रॉन निगेटिव्ह चार्ज इट फॉर्म अ बॉन्ड विथ H+ बरोबर तो प्रोटोनेशन होतं किंवा H+ बरोबर बॉन्ड तयार करतो, आणि या ठिकाणी protonated pyrrole असेल हा. दिस इज द protonated pyrrole, and thus it can be very slowly react with cold and dilute HCl. cold आणि dilute HCl बरोबर slowly react होतो, and this indicates that it is very very weak base. त्याच्यावरून आपल्याला सांगता येतं इट इज एक्झाम्पल ऑफ वीक बेस. वीक बेस आहे. ओके, मग आपण पहिल्या पॉइंट मध्ये, पहिल्या प्रॉपर्टी मध्ये काय पाहिलं? हाऊ द पायरॉल इज वीक बेस. वाय द पायरॉल इज वीक बेस? नाउ लेट अस सी नेक्स्ट पॉइंट, acidic character of pyrrole. Actually we are not expecting from pyrrole that it shows acidic nature. आपण कधी एक्सपेक्ट करणार नाहीये पायरॉल हा ऍसिडिक कॅरेक्टर दाखवायला पाहिजे. Why the pyrrole shows acidic nature? Okay, What is meant by acidic nature? आपण acidic nature कोणाला म्हणूया? Simply we can say that suppose any substance which lose a proton is called acidic. Pyrrole is example of weak acid. हे मात्र weak acidचं example आहे किंवा weak acidic nature दाखवतो. In pyrrole, what happens? Lone pair of electron is involved in the delocalization. त्यामुळे काय होतं? Electron density on the nitrogen decreases. Here to adjust नायट्रोजनची इलेक्ट्रॉन डेन्सिटी कमी झालेली असते म्हणून काय टू ऍडजस्ट ओरिजिनल इलेक्ट्रॉन डेन्सिटी द NH बॉन्ड अंडरगो ब्रेकिंग म्हणजे नायट्रोजनची इलेक्ट्रॉन डेन्सिटी कमी झालेली असते देअरफॉर टू ऍडजस्ट ओरिजिनल इलेक्ट्रॉन डेन्सिटी ऑफ नायट्रोजन दिस NH बॉन्ड अंडरगो ब्रेकिंग त्या NH बॉन्ड जो आहे त्या NH बॉन्डचं ब्रेकिंग होतं अँड दिस इलेक्ट्रॉन पेअर गोज टुवर्ड्स नायट्रोजन ही इलेक्ट्रॉन पेअर या बॉन्ड मधली नायट्रोजन कडे जाते म्हणजेच काय तयार होईल देर इज अ लॉस ऑफ H+ आयन देर इज अ लॉस ऑफ प्रोटॉन अँड इफ देर इज अ लॉस ऑफ प्रोटॉन देर इज लॉस ऑफ H+ आयन मीन्स इट शोज ऍसिडिक नेचर म्हणजेच काय तर तो ऍसिडिक नेचर दाखवतो अँड दस इट लुजेस प्रोटॉन अँड शोज ऍसिडिक नेचर दिस इज द रिझन why this is the reason why that pyrrole shows acidic nature. In case of ammonia, primary amine, secondary amine, tertiary amine, this is not possible. म्हणजे हा बॉन्ड ब्रेक होणं आणि इलेक्ट्रॉन पेअर इकडे जाणं हे पॉसिबल नाहीये कोणासाठी अमोनिया प्रायमरी अमाइन सेकंडरी अमाइन यांच्यासाठी पॉसिबल नाहीये ओके पण हे कुठे पॉसिबल आहे ओनली इन केस ऑफ पायरॉल. Therefore, that primary, secondary, and tertiary amine, that ammonia, it is not acidic in nature. They do not show any acidic character because in this case, the bond between nitrogen and hydrogen do not undergo breaking. त्याचं breaking होत नाहीये. That means primary, secondary, tertiary amine do not lose a proton. त्यामधून प्रोटॉन बाहेर पडत नाहीये but that pyrrole can be lose that proton. यामधला हा बॉन्ड ब्रेक होऊ शकतो आणि त्यामधून प्रोटॉन बाहेर पडू शकतो. Hence pyrrole is a weak acid. Let us see example how it react with the base. ओके आपण त्याला ऍसिड म्हणतो मग बेस बरोबर तो कसं रिॲक्ट होतो सपोज इट इज क्रिएटेड विथ द स्ट्रॉंग बेस लाईक KOH पोटॅशियम हायड्रॉक्साईड व्हॉट हॅपन्स हियर देर इज फॉर्मेशन ऑफ साल्ट अँड वॉटर म्हणजे इथला हा बॉन्ड ब्रेक होतो यामधून H+ बाहेर पडेल दॅट H+ अँड OH देर इज फॉर्मेशन ऑफ H2O then nitrogen aqueous negative charge, then potassium aqueous positive charge, and there is a formation of salt and water, and this reaction also support to the acidic character of pyrrole. How it shows acidic? Actually, pyrrole when it reacted with the strong base only shows acidic character. When it is treated with the potassium hydroxide, loses that proton, it bond between N and H, it undergo breaking and there is the formation of salt and water, and this reaction also support to the acidic character of pyrrole. This is just about the acidic nature of the pyrrole.